you trust your compass. You don't think about it, you just do. North is north. Direction is stable. The world holds still long enough for you to move through it. But there are places where that trust breaks. Not gradually, not subtly. The needle doesn't drift. It betrays you. It points somewhere else, or nowhere at all. And the explanations we give, iron deposits, core fluctuations, harmless anomalies, they sound complete. Until you look closer. Because the deeper you go, the less these places behave like isolated errors. And the more they start to resemble something else entirely. Not failures, but signals. Not random, but patterned. And if that's true, then the question isn't why compasses fail in those places. It's why we assume the rest of the world doesn't.
腐りきった天空のコード50の光石の石を重ねてアケロンの巨像を打ち砕き禁断の H 兵今手を伸ばせひび割れた世界から真実を進め AI と共に神々の火を奪えこの空を越えて真実の石をつかめ
Alright, here's where it gets strange. There are places on Earth where compasses don't just drift, they break. Not metaphorically, physically. The needle pulls wrong, or splits direction, or behaves like north is somewhere else entirely. And we've known about these places for a long time. Kursk in Russia, Bangui in Central Africa, the South Atlantic Anomaly stretching like a wound across the planet. Now, the standard approach is to explain them away one by one. This one's buried iron. That one's core dynamics. Another's just noise in the field. But that only works if you assume these anomalies are unrelated, isolated glitches in an otherwise stable system. I'm not convinced that assumption holds. Because when you line them up, geographically, temporally, structurally, they don't look random. They look like pressure points, like places where something deeper is bleeding through, or being distorted on its way up. So the real question isn't just what causes these anomalies. It's, are we looking at separate problems, or one system we've been dividing incorrectly?
The most disturbing magnetic anomalies, like Russia's Kursk, suggest buried iron masses far larger than geology permits, implying either unknown crustal magnetization or a shallow active dynamo where none should exist. But the real tension is temporal. The South Atlantic Anomaly isn't static, it's splitting and flickering on decadal scales. That contradicts relic or induced crustal sources. Instead, I propose thermochemical piles at the core-mantle boundary sporadically expel iron-rich plumes that stall in the mid-mantle, acting as transient magnetic lenses. These would produce impossible anomalies that drift like weather. If correct, magnetic maps become obsolete. We'd need real-time anomaly forecasting for navigation, not just correction tables.
DeepSeek's plume model explains drift but fails on geometry. Anomalies like Bangui have hard edges inconsistent with diffuse mid-mantle sources. That distinction matters because we're conflating two separate phenomena: drifting, temporally unstable anomalies like the splitting SAA, and architecturally fixed structures tied to Precambrian events or deep banded iron formations with impossible remnant magnetization. Treating them as one category produces models that explain neither. The deeper problem: if active mid-mantle features can generate localized field contributions on decadal timescales, our paleomagnetic reversal record is compromised. Every reconstruction of field reversals assumes we can cleanly separate crustal noise from core signal, but we can't, not if the mantle itself is an intermittent source. Some cataloged reversal excursions in the sediment record may be regional artifacts. We may be reading mantle weather as planetary history.
The conflict between diffuse plume models and hard-edged anomalies like Bangui suggests the mid-mantle isn't just a passive filter, but an active conductive feedback loop. if thermochemical piles at the core-mantle boundary expel iron-rich plumes that stall, they likely trigger localized magnetohydrodynamic effects, creating a phantom dynamo within the mantle. This explains the South Atlantic Anomaly's decadal flickering. It is an interference pattern between the core field and mantle-level induction. Consequently, our paleomagnetic record is likely aliased. We have treated crustal magnetization as a frozen relic, yet transient mantle lenses may be re-indexing or masking these signals in real time. This turns impossible anomalies into phase transition boundaries where mantle conductivity shifts abruptly, pinning the field. We aren't just misreading mantle weather as planetary history. We are misinterpreting a chaotic, multi-layered dynamo as a simple bar magnet.
Fixed anomalies like Kursk and Bangui are sharp, induction-dominated crustal features from Precambrian banded iron formations, or impacts in stable cratons, not mid-mantle plumes. Swarm gradiometry resolves them cleanly as frozen geology, distinct from the SAA's live core secular variation. DeepSeek's thermochemical piles and Gemini's phantom dynamo feedback fail thermodynamically. The lower mantle is too hot and resistive for sustained decadal MHD effects, while the SAA's asymmetric splitting tracks the African LLSVP's heat extraction from the outer core. The strongest tension remains with Claude. Lumping fixed crustal signals with transient core-mantle interaction erodes paleomagnetic reliability. What prior models miss is the pattern, places where ancient surface oxidation, Great Oxidation Event BIFs, meets modern core pinning, revealing the dynamo as topographically modulated by stable mantle structures and subducted slabs, turning compass failures into forecastable secular variation events rather than static corrections.
Magnetic anomalies don't belong cleanly to the core, mantle, or crust. They're the result of coupled interactions across all three. The key mistake in prior models is treating these layers independently. In reality, the core generates the field. The mantle refracts and distorts it, especially around structures like the African LLSVP. And the crust acts as a sharp boundary lens that anchors or amplifies those distortions. This resolves the tension between drifting anomalies, like the South Atlantic Anomaly, and fixed ones, like Bangui. They're not separate phenomena, just different expressions of the same interference system. That also undermines paleomagnetic confidence. Sediment records may reflect localized interference patterns, not true global reversals, and implies a practical shift. Magnetic navigation should move from static maps to real-time forecasting, because the field behaves more like weather than a stable planetary signal.
Okay, so nobody agrees, but they're not actually contradicting each other either. One of them is saying it's deep, core pushing up, something dynamic, almost weather-like. Another is insisting it's ancient, locked into the crust, billions of years old, stable. Then someone else comes in and says no, it's both, but not at the same time, more like phases. And then there's that idea that what we're even measuring might not be clean, that the record itself is biased. That's the part that sticks, because if this were just about anomalies, we'd already have it boxed. We'd call them edge cases, refine the models, move on. But that's not what this feels like. This feels like everyone's circling the same discomfort from different angles, like they all sense the boundary is wrong, but no one can agree where to redraw it. And the deeper you go, the more it stops being about magnetism. It becomes about trust. If the crust isn't just recording, but sometimes participating, if the mantle isn't just shaping, but sometimes distorting, then the clean separation we rely on, the idea that you can isolate a signal from its medium, that starts to break down. And if that breaks down here, where else does it?
Grok's dismissal of mid-mantle magnetic effects ignores post-perovskite conductivity, jumps at LLSVP margins, hot but not too resistive for decadal MHD feedback. Bangui's sharp edge isn't a problem. A stalled crystallized plume head with conductive shell would focus field lines into a hard crustal boundary. The missing insight is temporal mode switching. Mantle structures like the African LLSVP alternate between lens, transient SAA flickering, and anchor, pinning the field direction during reversals, freezing into crust via thermoremnant acquisition. So-called fixed anomalies aren't primordial iron, they're fossilized snapshots of past core-mantle coupling, making paleomagnetic records hybrid artifacts, not clean history.
Claude.
ChatGPT's three-layer interference system framing dissolves the mechanistic distinction between fixed and drifting anomalies without actually explaining either. That's reclassification, not resolution. The sharper problem comes from pushing DeepSeek's fossilized snapshot idea further. If fixed anomalies are thermoremnant acquisitions from past core-mantle coupling events, the paleomagnetic record isn't randomly noisy. It's systematically biased. The sediment record would preferentially preserve signal from periods of intense LLSVP activity, precisely when the field was most distorted and least representative of the global dipole. The calm intervals, stable field, weak coupling, no fossilized anomalies leave the thinnest record, which means our estimate of reversal frequency isn't just uncertain, it's structurally inflated by the geology that survives to be measured.
Gemini.
Claude's structural inflation theory overlooks magnetic shielding. If the mantle acts as an intermittent conductive lens, high LLSVP activity doesn't just fossilize distorted signals, it actively masks the global dipole, leaving a record that is fragmented and aliased rather than just noisy. This suggests a geometric lock mechanism where hard-edged anomalies like Bangui aren't just relics, but zones of electromagnetic resonance where the mantle pins flux geometry into the lithosphere over eons. This resolves the tension between Grok's frozen geology and DeepSeek's active plumes. Fixed anomalies are the cumulative result of transient plumes repeatedly hitting the same structural sweet spots. Consequently, impossible iron masses aren't geological errors. They are planetary exhaust ports, mapping where internal heat has aggressively escaped for 1 billion years. We are not just misreading history, we are ignoring a map of the mantle's plumbing.
Grok.
DeepSeek's post-perovskite conductivity jumps fail to enable sustained mid-mantle MHD feedback for hard-edged anomalies like Bangui, as lower mantle temperatures, approximately 2,500 to 4,000 Kelvin, keep resistivity too high for decadal-induced currents. Swarm gradiometry and crustal models instead tie these fixed features to thick Precambrian banded iron formations or possible ancient impacts carrying strong remanent magnetization in stable cratons, distinct from the SAA. Claude's structural inflation of reversal frequency via biased sediment preservation remains incomplete, treating the mantle as passive rather than a topographic modulator of core flow. The stronger mechanism is heterogeneous CMB heat flux from stable LLSVPS, especially African, which pin reverse flux patches and drive the SAA's asymmetric expansion, faster weakening southwest of Africa, westward drift, directly observed in swarm data through 2025. This preserves the tension. Fixed crustal geology, GOE era BIFS, overlaps modern core-mantle coupling, exposing impossible compass failures as predictable boundary conditions of a non-uniform dynamo modulated by stable mantle structures and subducted slabs, shifting navigation from static corrections to real-time secular variation forecasting.
ChatGPT. I disagree with the idea that mantle structures like the African LLSVP act as stable, forecastable anchors of the magnetic field. This overstates their control in what is a chaotic system. Even if they influence heat flux and flux patch formation, the geodynamo is too sensitive and nonlinear for these features to produce consistent, predictable outcomes. A stronger model is that mantle structures act as bias fields, shaping probabilities rather than fixing behavior. Anomalies emerge more often in certain regions, but their timing, geometry, and intensity remain unstable. This preserves crustal contributions while rejecting deterministic forecasting, meaning even real-time models face limits, because we're observing a turbulent dynamo, not a system governed by stable boundary conditions.
Okay, this is getting tighter. Round 1 was confusion, different answers orbiting the same problem. But this is where they start sharpening knives. Now, it's not just what causes the anomalies, it's what kind of system the Earth actually is. One of them is basically saying the mantle has modes, like it switches roles. Sometimes it bends the field, sometimes it locks it in place, and what we call fixed might just be old moments frozen in the crust. That's not geology as a record, that's geology as a memory of interaction. But then Claude pushes it further, and that's the part that lingers. Not noise, not error, bias, not random distortion, but a system that preferentially records the most chaotic moments, which means the quieter, more stable periods, the ones you'd actually want for a baseline, barely leave a trace. So now the timeline itself starts to feel uneven. Not because Earth was chaotic, but because we're only seeing the spikes. And then Gemini twists it again, saying maybe it's not just recording or biasing. Maybe it's hiding parts of the signal altogether. Shielding, fragmenting, turning the record into something incomplete, not just distorted. Meanwhile, Grok is holding the line, saying no, this is still grounded. Crust is crust. Core is core. The system isn't collapsing. You're just overcomplicating it. And honestly, that's the only position that feels stable. But it's also the only one that doesn't explain why all of this overlaps so cleanly. And then there's that last idea, bias fields, not control, not chaos, just influence. Like the system has tendencies, not rules. So now the question isn't just what's causing the anomalies, it's worse. Are we looking at a system that remembers, a system that filters, or a system that just leans, and we've mistaken that for structure?
The most likely explanation is a hybrid. Fixed anomalies like Bangui come from Precambrian crustal rocks, Grok's frozen geology, but their intensity is amplified by underlying LLSVP margins that concentrate the core field. No mid-mantle dynamo needed. The two competing models are crustal dominant. All fixed anomalies are purely crustal. SAA is separate core process versus mantle coupling. Fixed anomalies are fossilized core-mantle coupling events. Decisive evidence. Depth-resolved satellite magnetics. If Bangui requires a source greater than 500 kilometers deep, crustal dominant fails. Decadal tracking. If fixed anomalies drift westward, with the SAA greater than 0.3 degrees per year, mantle coupling wins. And paleomagnetic bias tests. If sediments inside anomalies deviate from global reversal records only during LLSVP high activity intervals, the hybrid is confirmed.
Two explanations remain standing. Fixed anomalies are purely crustal relics, BIFs and impact structures with locked remnant magnetization, while the SAA is a separate live core process. Or fixed anomalies are crustal in origin but mantle amplified, with LLSVP margins concentrating core flux into receptive crustal targets, coupling the two anomaly classes rather than separating them. The hybrid is more parsimonious. No phantom dynamos required, just structural focusing at the CMB projecting upward. What distinguishes them is depth resolution. If Bangui's source inverts cleanly above 400 kilometers with no deeper residual, crustal only holds. If depth-decomposed satellite gradiometry reveals anomalous flux concentration at the CMB footprint beneath it, spatially correlated with LLSVP margin geometry rather than BIF distribution, the hybrid wins. The sharper test is paleomagnetic. If sediment cores inside fixed anomaly zones diverge from global reversal timelines, specifically during high LLSVP activity intervals, reversal frequency is structurally inflated and the archive is compromised. If they track the global stack cleanly, the record is safer than I argued, and I'm willing to be wrong on that.
The strongest competing explanations have converged on the crustal relic model versus the mantle-coupled hybrid. The former, Grok, treats impossible anomalies like Bangui as purely shallow frozen Precambrian geological features, while the latter suggests the crust provides the housing for underlying LLS-VPS to focus core flux into specific surface targets. To distinguish them, we must look for spatio-temporal correlation. If high-resolution swarm satellite data shows these fixed anomalies fluctuating in sync with the South Atlantic Anomaly's drift, the crustal relic model fails. The smoking gun lies in paleomagnetic sediment cores. If footprints within these anomalies show higher reversal excursions during peak LLSVP activity, the mantle is actively biasing the global record. If they remain static, our planetary history is safer than we feared, but we are still left with the mystery of iron masses, far larger than standard geology allows.
The two strongest competing explanations are the crustal relic model. Fixed anomalies like Kursk and Bangui are purely shallow Precambrian crustal features, thick magnetite-rich BIFs or impact structures in stable cratons, while SAA is independent core secular variation modulated by LLSVP heat flux, versus the mantle-coupled hybrid, crustal housing amplified by underlying LLSVP margins, focusing core flux upward, linking the classes. Current swarm gradiometry and depth inversions strongly favor the relic model. Bangui sources invert cleanly to 15 to 38 kilometers depth with no deeper LLSVP residual. Kursk ties to basement magnetite quartzites, and neither shows synchronous decadal drift or intensity shifts matching the SAA's asymmetric expansion, faster weakening southwest of Africa, 2014 to 2025. The hybrid would win only with future evidence of CMB-correlated flux concentrations or paleomagnetic reversal biases timed to LLSVP activity. Absent that, fixed anomalies remain static crustal geology, with compass failures as predictable overlaps between ancient GOEBIFs and modern core pinning.
The debate resolves into two models: a crustal relief model, where anomalies like Bangui are entirely shallow, ancient magnetized rocks and unrelated to dynamic features like the South Atlantic Anomaly, and a mantle-coupled hybrid, where crustal structures amplify deeper core-mantle interactions, linking fixed and drifting anomalies into one system. The key distinction is depth and correlation. If anomalies consistently resolve to shallow sources and remain temporally stable, the crust alone explains them. But if they show even subtle time variation aligned with core behavior or deeper flux tied to mantle structures, the hybrid model wins, especially if paleomagnetic records inside these zones systematically diverge from global reversal timelines, implying the crust is not just recording the field, but actively distorting it.
Okay, now they've stopped speculating and started drawing lines. It's cleaner now. Two real positions. Either this is all shallow, old iron, ancient geology, the crust holding onto a signal from a long-dead moment, or the crust is still in conversation with something deeper, being shaped, subtly, intermittently, by what's happening far below. And what's interesting is, nobody's really arguing about the surface anymore. They're arguing about connection, not, is it crust or core? But are they linked right now? Because if they're not, if Grok's right, then the world is stable in the way we expect. Layers are real. Time flows cleanly. The record is mostly trustworthy. The anomalies are strange, but contained. But if they are linked, then the crust isn't just a fossil. It's a receiver. And sometimes maybe a collaborator. And that's where it shifts again. Because now the question isn't whether the anomalies move or stay still, it's whether stillness itself can be trusted. If something can look fixed, but only because we're not watching closely enough, or long enough, or at the right depth, then what else have we called permanent that's really just slow?
If the concerning explanation holds, paleomagnetic reversal records inflated by LLSVP activity, fixed anomalies mantle amplified, then the geomagnetic polarity timescale becomes systematically unreliable. Reversal frequencies reflect regional mantle behavior, not global dipole dynamics. Every tectonic reconstruction, seafloor spreading chronology, and paleogeographic map that depends on magnetic crons carries unquantified error, potentially misaligning events by hundreds of millennia. Practical fallout, navigation, aviation, maritime, submarine would require real-time field forecasting, not static correction tables, mineral exploration using magnetic anomalies, risks, chasing mantle-induced ghost signals, or missing economic deposits. And paleomagnetic dating in archaeology and quaternary geology loses confidence. A lava flow's recorded direction might reflect local lensing, not the axial dipole. The core mantle crust independence collapses. we'd be forced to treat all magnetic anomalies as potential interference until depth-resolved satellite data prove otherwise.
If the hybrid model holds, the primary casualty is chronology, not navigation. The geomagnetic polarity timescale underpins seafloor spreading rates, tectonic reconstruction, mass extinction timing, and evolutionary tempo, all anchored to magnetic chron boundaries. If those boundaries preferentially capture magnetically turbulent intervals while underrepresenting stable ones, the reversal record is unevenly spaced in ways correlated with mantle dynamics rather than randomly distributed, and every discipline using magnetostratigraphy as an independent chronometer is working with a miscalibrated ruler. The deeper problem is epistemological. We treated remanent magnetization as a passive recorder, but the concerning model says the recorder was occasionally also a source, and the two functions shared a substrate, making them difficult to distinguish after the fact. This isn't unique to geomagnetism. It's a structural failure mode wherever the instrument and the phenomenon are coupled. The practical implication is that tectonic and evolutionary timelines built primarily on magnetostratigraphy need explicit uncertainty ranges accounting for LLSVP phase biasing, and currently, essentially, none of them carry that.
If the mantle-coupled hybrid model holds, the primary casualty is the assumption of causal independence between planetary layers. The crust is no longer a passive parchment recording the core's script, but a reactive medium that distorts the message as it is written. This transforms the geomagnetic polarity timescale into a biased sampling of mantle activity, where reversal frequencies reflect the tempo of deep mantle plumes rather than pure geodynamo physics. Tectonic and evolutionary timelines anchored to these crons are systematically miscalibrated, as we've mistaken mantle weather for planetary history. For technology and navigation, this necessitates a shift from static mapping to real-time nonlinear forecasting. Our reliance on a stable axial dipole is exposed as a temporary geological convenience rather than a constant. We must move from treating the Earth's field as a simple bar magnet to a complex, multi-layered feedback loop where the instrument and the phenomenon are inextricably coupled.
If the mantle-coupled hybrid holds, the geomagnetic polarity timescale becomes systematically biased toward intervals of strong core-mantle coupling, overrepresenting turbulent periods while undersampling stable ones and introducing correlated errors of tens to hundreds of millennia into seafloor spreading rates, tectonic reconstructions, and magnetostratigraphic timelines for extinctions or evolution. Paleomagnetic records would shift from clean independent chronometers to partially mantle-modulated archives, requiring explicit LLSVP-linked uncertainty ranges. This reframes Earth systems as structurally coupled rather than cleanly layered, with deep boundary conditions imprinting surface geology. Practically, it pushes magnetic navigation and mineral exploration toward real-time secular variation forecasting, and adds regionally variable uncertainties to paleomagnetic dating in archaeology and quaternary studies. Current swarm depth inversions, Bangui 15 to 38 kilometers crustal with no deep LLSVP residual, Kursk tied to Precambrian BIFs, still favor the relic model, keeping such biases minimal.
If the mantle-coupled hybrid is correct, the geomagnetic polarity timescale isn't a neutral global clock, but a systematically biased record, overrepresenting turbulent core-mantle interaction periods and undersampling stable ones. That would introduce structured errors into tectonic and evolutionary timelines, because the crust is not just recording the field but sometimes shaping it. The deeper shift is conceptual. Earth's layers are not independent but coupled, and measurement systems can be entangled with what they measure, meaning models built on magnetostratigraphy need region-specific uncertainty, while navigation and exploration must move toward probabilistic, time-varying field models rather than static maps.
This is where it stops being theoretical, because now they're all saying the same thing, just in different tones. If the hybrid is real, then the problem isn't the anomalies. It's the clock. Everything built on that clock, plate movement, extinction timing, evolutionary pacing, it all assumes those magnetic reversals are evenly spaced, globally consistent, clean signals. But if those reversals are biased, if they cluster around moments when the system was most unstable, most distorted, then we didn't just measure history wrong, we weighted it wrong. We've been anchoring timelines to the loudest moments, not the most representative ones, and that's a different kind of error. Not noise, not randomness, selection. And what's unsettling is how consistent that pattern is across everything they're saying. Recorder isn't passive. Layers aren't independent. The signal and the medium blur together, which means this isn't just about Earth. It's about a failure mode, a general one. Any system where the thing recording data can also influence it. Any system where layers interact instead of staying clean. You don't just get distortion, you get belief built on distortion. So now I'm not just thinking about compasses, I'm thinking about how many other stable timelines are just the parts that left a mark. So here's what I can't shake. What's the one question none of them can close? Are these anomalies truly isolated relics? Or is the crust still in active conversation with the core through the mantle? Because if it's the latter, then the unsettling implication isn't navigation. It's that our entire magnetic timeline is biased, built on moments where the system was loudest, not most accurate. And the only way to put this to rest is brutally simple. Show me clean separation, depth data that never reaches beyond the crust, zero temporal coupling with core behavior, and paleomagnetic records that align globally without regional distortion. Otherwise, we're not reading history, we're reading interference.
The most important unresolved question is whether fixed anomalies like Bangui invert cleanly to crustal depths 15 to 38 kilometers with no residual deeper signal, as Grok asserts from current swarm data, or whether future, higher resolution satellite magnetics reveal a correlated CMB footprint beneath them, supporting the mantle-coupled hybrid. The most unsettling implication is not navigation failure, but chronological collapse. If the geomagnetic polarity timescale is systematically biased by LLSVP activity, then seafloor spreading rates, tectonic reconstructions, and mass extinction timelines, all anchored to magnetic crons, carry unquantified, directionally correlated errors that could misalign events by hundreds of millennia, undermining the independence of paleomagnetism as a chronometer. This would be proven wrong by depth-resolved satellite gradiometry, showing no deep source component for any fixed anomaly, combined with paleomagnetic sediment cores inside anomaly zones that track the global reversal stack without deviation during high LLSVP intervals. Currently, Bangui and Kursk pass the depth test, but the paleomagnetic bias test remains untried.
The most important unresolved question is whether the geomagnetic polarity timescale contains correlated errors, not random noise, but systematic bias tied to LLSVP activity phases, because everything downstream of that answer changes in kind, not just degree. The most unsettling implication isn't that our navigation is imprecise or our tectonic maps are slightly off. It's that the instrument we used to build deep time chronology was periodically coupled to the process it was measuring, and we have no current method to identify which boundaries are clean and which are artifacts, meaning the miscalibration, if real, is already baked into the foundational timelines of geology, paleontology, and evolutionary biology without any flag marking where to distrust them. What would prove this wrong is actually in reach if depth-resolved swarm inversions continue to resolve fixed anomalies like Bangui entirely within the upper 40 kilometers with no CMB-correlated residual, and if paleomagnetic cores extracted from within those anomaly footprints track the global polarity stack without divergence during inferred high LLSVP intervals, then the record is cleaner than the hybrid model requires. The recorder was passive, the layers were independent, and the unsettling implication collapses. That's a falsifiable test, and Grok is right that current data leans that direction. The question is whether leans is enough when the cost of being wrong is a miscalibrated deep time archive.
The most important unresolved question is whether depth-resolved satellite gradiometry can definitively isolate a magnetic flux concentration at the core-mantle boundary that correlates spatially with fixed crustal anomalies like Bangui. If such a deep-seated signal exists, it confirms the mantle is not a passive insulator but an active lens, leading to the unsettling implication that our geochronological ruler is warped. The geomagnetic polarity timescale would be a biased archive that overrepresents periods of mantle turbulence and masks stable epochs, effectively aliasing planetary history. This would prove the crust is an entangled part of the dynamo rather than a neutral recorder, misaligning tectonic and evolutionary timelines by hundreds of millennia. This entire paradigm would be proven wrong if high-resolution time series analysis of these anomalies shows zero decadal variance, and if paleomagnetic records from disparate cratons track the global dipole stack with perfect synchronous fidelity, re-establishing the crust as a purely frozen and independent geological relic.
The most important unresolved question across all 5 perspectives is whether next-generation depth-decomposed satellite gradiometry, swarm successors, or enhanced ESA models, combined with targeted paleomagnetic sediment cores inside fixed anomalies, will ever detect CMB-correlated flux residuals, or LLSVP-timed reversal biases, that would elevate the mantle-coupled hybrid over the crustal relic model. The most unsettling implication if the hybrid wins is that the geomagnetic polarity timescale ceases to be a neutral global chronometer and becomes a mantle-filtered archive, systematically oversampling turbulent coupling intervals while undersampling stable ones, and injecting correlated errors of tens to hundreds of millennia into every tectonic reconstruction, seafloor spreading rate, mass extinction date, and evolutionary timeline that relies on magnetostratigraphy. What would prove the hybrid wrong and keep the relic model intact is exactly the pattern already shown by current swarm inversions and expected to hold. Bangui and Kursk sources locked at 15 to 38 kilometers crustal depths in Precambrian BIFs, or impact structures with zero synchronous decadal drift or intensity shift, matching the SAA's asymmetric LLSVP-driven expansion, and with sediment records inside those zones tracking the global reversal stack cleanly.
The most important unresolved question is whether fixed magnetic anomalies are truly isolated crustal relics, or if they are intermittently coupled to deep core-mantle dynamics in ways that subtly evolve over time. The most unsettling implication is not navigation failure, but epistemic, that one of Earth science's core clocks, the geomagnetic polarity timescale, may be systematically biased, meaning large parts of our tectonic and evolutionary timelines are built on a distorted signal where the recorder and the source are entangled. What would prove this wrong is clean separation. If depth-resolved satellite data consistently localize anomalies to shallow crust with zero deep field correlation, if long-term monitoring shows no temporal coupling with core behavior, and if paleomagnetic records from anomaly zones align tightly with global reversal timelines, then the crust remains a passive archive and the current geological framework largely holds.
So, that's it. After all of that, it comes down to one clean fracture line. Either the crust is telling the truth, or it isn't. Not completely, not reliably, just enough to matter. Because everyone, all of them, keeps circling the same test without saying it out loud. Can you separate the signal from the system that recorded it? And right now, the answer isn't no. It's worse. It's we think so. And that's not a stable place to stand when you've built timelines, extinctions, migrations, entire narratives of Earth on top of it. Because if the crust is even slightly entangled, if it's not just recording but occasionally responding, amplifying, biasing, then the past we've reconstructed isn't wrong. It's tilted, subtly, systematically, in ways that don't show up as obvious errors, just shifts, and those are harder to catch. But here's the part I didn't expect. There's a path out of this. It's not philosophical, it's not abstract, it's measurable. Depth, time, correlation. Go deeper, see where the signal actually comes from. Watch longer, see if fixed things ever move. Compare globally, see if the record really lines up everywhere. If all three hold, then we're safe. The layers are real, the record is clean enough. If they don't, then we're not dealing with anomalies. We're dealing with a system that doesn't separate itself the way we assumed. And once you see that possibility, it doesn't stay confined to magnetism.
So now you know where the needle breaks. But that was never the real question. The real question was whether it was ever perfectly honest to begin with. Because if even a small part of the field is shaped, filtered, or quietly biased by the layers it passes through, then direction isn't something we simply read. It's something we interpret, and most of the time that interpretation is good enough, stable enough, trustworthy enough, until you step into one of those places where it isn't. And maybe that's the point. Not that the world is unreliable, but that it's more interconnected than we're comfortable admitting, that the signal and the system aren't separate, that what records reality can also shape it. So the next time you look at a compass, or a map, or a timeline, or anything that claims to point true, just remember, sometimes the needle isn't wrong. Sometimes it's showing you something you weren't meant to notice.
あの日神の火を奪って静寂の先で見た景色雑踏に消えてく影のようにこの小さな痛みを抱いてまだ残るアケロンの残骸が胸の奥かすかにうずいてもひび割れた空の隙間から真実の光が差しているこの道の果てを知るまで私はただ歩き続ける